back to another expert Q&A session with Angst+Pfister. Today we're at the Innovation Park in Zurich, Switzerland, and we're taking a closer look at a key challenge in electric and hybrid drivetrains: managing NVH, noise, vibration and harshness. As a technology partner, Angst+Pfister has developed a novel anti-vibration solution to meet the specific demands of modern e-mobility platforms. Joining me today is Daniel Chidley. He is a senior engineer in anti-vibration and sealing technology and has been with Angst+Pfister for more than 6 years. Welcome, Daniel.
Thank you for having me.
Thank you for being here and answering our questions. So, Daniel, which NVH challenges do electric and hybrid powertrains pose that traditional anti-vibration mounts struggle to address?
So compared to internal combustion engines, electric motors and electrical vehicles and hybrid vehicles generate more high-frequency excitations in the range of 200 to even 2000 hertz. And those excitations cause dynamic hardening in the rubber, which increases the transmissibility of noise and vibrations into the vehicle itself. And on the other hand, the vehicles obviously are becoming more quieter, and therefore the high frequency noises are more apparent. Therefore the need to isolate as much as possible these high frequency noises and vibrations.
And how does the new Angst+Pfister mount improve the NVH performance?
So there's two aspects. The rubber itself is a viscoelastic material and hardens as you increase the frequency of the load. And we optimize and develop the rubber compounds to minimize that hardening effect. And we have special rubbers which are specifically developed for this sort of application. And on the other hand, the design also plays a role where the rubber itself can resonate at certain frequencies, and that resonance also gives a stiffening effect. So we also work on the design, optimize the design, and use simulation tools to predict how the behavior of the mount will be under dynamic conditions. And we can also optimize the design for those dynamic applications, and we can also add specific features like here, these wing features which act as mass dampers, and they actually break up the resonance of the rubber itself, the main rubber body. So with those two tools we can optimize and really have the best mount for electrical vehicles.
And what makes this mount more efficient and lightweight compared to conventional solutions in the industry?
So for this specific mount, we integrated the snubber function, which is this axial stopper here, which normally is a separate washer, which increases the complexity and the cost and the weight and everything. And we've integrated it into one single piece design. And that reduces the weight by being simpler. And also we have plastic over molding. We also have lightweight pocket features, which are specifically designed to reduce the weight as well. And it's the metals, if it's a lightweight application, also is usually aluminium to reduce the weight.
How does this solution support the shift toward electrification and sustainability in the mobility and machinery industry?
Yes, so on top of all the other requirements, electrification and sustainability adds another level. And like I said, we optimize the compound for the NVH performance for electrical vehicles, and also we test and optimize the rubbers for lifetime, and lifetime is a big aspect of sustainability. And on the other hand, also because it's a simpler design with less components, it it has a simpler bill of materials, which also reduces the waste and has a more sustainable impact. Yes.
And for the last question, Daniel, can you tell me about the benefits for engineering and procurement teams adopting this new mount?
So for engineering, obviously, we meet all the requirements engineering-wise in terms of stiffnesses in all directions, also the dynamic performance, the lifetime, keeping the assembly simple and easy, and for procurement, we reduce the total cost of the part by having a simpler design, less tooling required, and lower bill of materials.
Thank you very much, Daniel, for sharing your expertise with us today.
That's okay, thank you for having me.
And for everyone else interested in learning more about this novel anti-vibration solution, check out the link in the description below, linking to our newest Solutions Hub blog post.